Gay-Lussac's law. Gay-Lussac's law is the directly proportional relationship between temperature and pressure.
Using the equation P1 over T1 equals P2 over T2, P being pressure and T being temperature. To demonstrate this law, we will be doing two experiments. The materials for the first include a shelled hard-boiled egg, a glass bottle, a lighter, and flammable paper. The procedure for this experiment is to light the paper on fire, place the lit paper in the bottle, and place the egg on top of the bottle. The egg is quickly pulled into the bottle due to the fact that as the temperature increased inside the bottle from the fire, the pressure did as well. But when the paper is extinguished, the temperature and pressure decrease together, and the low pressure pulls the egg. The pressure inside the bottle before the paper was placed inside was about 1 atm and the temperature was about 296 Kelvin. After the lit paper was placed, the temperature rose to about 506 Kelvin. In order to find the pressure of the bottle after the fire was placed inside, we need to use Gay-Lussac's law formula, which is P1 over T1 equals P2 over T2, with P being 1 atmosphere, T1 being 296 Kelvin, T2 being 506 Kelvin, and P2 being our variable. In order to solve this, we need to fill the Gay-Lussac's law with the data, which would leave us with 1 atmosphere over 296 Kelvin equals x over 506 Kelvin, which could then be simplified to 1 over 296 equals x over 506. You then isolate it by multiplying by 506. This would then leave you with the temperature in the bottle after the fire at 1.709 atmospheres. After finding the second pressure, we can reinsert it into the Gay-Lussac's law formula, which would leave us with 1 atmosphere over 296 Kelvin equals 1.709 atmospheres over 506 Kelvin. We can observe that both the pressure and the temperature about doubled, thus the Gay-Lussac's law is correct, because they truly are proportional.
For the next experiment, we need a can with a small quantity of water, cold water, a stove, and tongs. The procedure is to put a small amount of water in the can, heat can over stove with tongs until the water boils, and quickly plunge it into the cold water. This experiment is very similar to the previous one, only now we heated water vapor, so it would expand and the pressure in the bottle would increase. Then we quickly cooled the gas down and the pressure decreased, which made the can implode. In order to find the pressure of the can, we again used Gay-Lussac's law. First, we need to find the pressure of the can over the stove, so we start out with the condition of the can before it was heated. Pressure equals 1 atm, T1 equals 296 Kelvin, and T2 equals 373 Kelvin. P2 equals x. Putting these all in the Gay-Lussac's law formula, you get 1 atmosphere over 296 Kelvin equals x over 373 Kelvin. Solve for x, and the pressure of the heated can is 1.26 atm. The temperature of the can after being submerged in the cold water was about 278 Kelvin. So using the data from the heated can, P1 equals 1.26 atm, T1 equals 373 Kelvin, and T2 equals 278 Kelvin. P2 equals x. Then insert the data into the formula. 1.26 atm over 373 Kelvin equals x over 278 Kelvin. Then solve for x. 0.003378 equals x over 278. X equals 0.939 atmospheres. When reinserted into the equation, 1.26 atmospheres over 373 Kelvin is proportional to 0.939 atmospheres over 278 Kelvin. In conclusion, Gay-Lussac's law is true, because pressure and temperatures do rise and fall together, as they did in both experiments, and when the sets were compared they were both proportional. Thank you for watching.